What if the universe has no end? A question like a hairline crack in the wall of our understanding, making everything we thought we knew about space feel as fragile as stardust. If no boundary truly exists, then perhaps every cosmic map we've drawn is nothing more than a faint sketch on an infinite silk canvas. Today, we step into a realm where measurements hesitate, where scale itself, so trusted by our intuition, quietly slips from our grasp. Leave a comment and tell me where you believe the universe ends or begins. And to understand any of this, we must start with a single question. When we shrink the universe, what did we misunderstand about scale? In the quiet center of the mind where thought drifts like slow starlight, a question rises with the soft gravity of wonder. If the universe is infinite, how could our earliest mechanical model of it, the delicate clockwork, orrery, mislead us from the very first turn of its tiny brass planets? The answer begins with scale, with the fragile limits of human perception, and with the simple truth that our hands can build only what our minds can hold. The orrery was a beautiful illusion, a universe that could fit on a wooden table, a cosmos that turned obediently beneath the flicker of candlelight. But beauty is not accuracy, and familiarity is not truth. When we imagine the earth as the size of a polished marble, the sun would not stand beside it as a modest sphere. Instead, it would swell into something vast, something overwhelming, something that would dwarf the room that holds the orrery itself. Astronomer Arthur Eddington once said, "Not only is the universe stranger than we imagine, it is stranger than we can imagine." And perhaps no comparison reveals this more gently or more painfully than the simple truth of their sizes. The Earth 1,000th of the Sun's radius, the Sun capable of swallowing 1,000,000 Earths without noticing the taste. These are not proportions the human mind evolved to understand. We were shaped by rivers and trees, mountains and storms, all things whose edges we can trace with our eyes. The universe does not share this courtesy, and so when we shrink it into handheld form, our intuition rebels. Even the act of scaling becomes a distortion, because a universe without boundaries cannot be folded into boxes, cannot be rendered into neat mechanical arcs. The orrery whispers a comforting lie, that the cosmos is a family of well-behaved siblings resting close to one another, that the sun is a warm elder at the center of a tiny village. But in truth, the earth is a pale bead drifting at a distance so great that sunlight takes 8 minutes to reach it. A distance so enormous that reducing it to a tabletop destroys its meaning. And what is meaning in a universe of such magnitude, where distances are measured not in steps nor miles, but in the journeys of light itself? Carl Sagan once wrote, "We are a way for the cosmos to know itself." Yet the cosmos knows itself through scales we cannot truly inhabit, scales that stretch far beyond the gentle reach of human intuition. This is why shrinking the universe misleads us, because compression is not comprehension, because proportions that feel right to the hand do not feel right to the sky. When we take the earth and sun and place them in the same room, we are performing a kind of poetry, but not a truth. Even our greatest visualizations stumble on this simple fact. Scale is not a trick of measurement. It is a dimension of reality. And every time we try to compress the universe to understand it, we compress ourselves instead, folding our perception into shapes that feel comfortable, even when they are false. Human intuition is built on the middle world, the realm between the very small and the very large, a realm of objects that neither vanish into quantum haze nor collapse into cosmic shadows. The physicist Richard Feynman once said, "Nature's imagination is so much greater than man's." And that imagination expresses itself through proportions that refuse to fit within our fragile habits of thought. When we shrink the sun into a ball we can hold, we betray its true identity as a roaring sphere of nuclear fire, a gravitational monarch pulling worlds into motion. When we shrink the distances between planets into a few spare inches, we erase the vastness that shapes orbits, seasons, and the fragile conditions that allow us to live. And when we shrink the universe itself, we commit the softest and most human of errors, believing that what fits into our hands also fits into reality. Our ancestors built models because they needed the sky to feel close. They needed the stars to become neighbors. They needed the universe to resemble something that could be understood. But scale is the language the universe uses to remind us of humility, brushing against our certainty like a cold current of interstellar wind. Imagine standing in an open field at night, the air still, the stars scattered like ancient fire across the dome above. In that silence, the mind naturally compresses the sky, making the stars seem nearer, making the cosmos feel almost touchable. But nothing about that sky is close. The nearest star beyond the sun is so far that a beam of light, the fastest traveler in existence, takes more than 4 years to reach it. Every intuitive sense we possess whispers the wrong story. Not because we are foolish, but because we evolved to survive, not to comprehend the infinite. The challenge is not that the universe is too large, but that our intuition is too local, too rooted in the scale of the body, the village, the horizon. When we shrink the universe, we drag it down to our native scale, a scale that protects us from the vertigo of the infinite. Yet the infinite persists, stretching outward in every direction, singing in wavelengths our eyes cannot see, vibrating in distances our minds cannot anchor. The orrery was a beginning, a gesture of reverence rather than accuracy, a promise that we would continue looking outward. But its simplicity is also a reminder that the universe is not required to match our imagination, nor to obey our comforting illusions of proportion. When we hold a small metal earth between our fingers, we forget that real earth is wrapped in storms, oceans, tectonic breath, and a magnetic halo shielding delicate life from cosmic violence. When we set the sun on a brass spindle, we forget the way its fusion pulses, the way its light takes tens of thousands of years to crawl from the core to the surface, the way its gravity sculpts the architecture of space. The universe does not shrink simply because we ask it to, nor does truth compress neatly into our expectations. So when we zoom out, letting the true proportions of Earth and Sun rise into view, something shifts inside us. We feel the distance, the imbalance, the humility. We feel the truth that our ancestors sensed but could not measure. That we live in a cosmos whose scale is not meant to be comfortable, but meant to awaken wonder. And in that realization, something quiet unfolds. A recognition that the infinite does not fit into our hands, but it does fit into our curiosity. Perhaps that is enough. In the stillness between heartbeats, when the mind quiets and the world softens into a gentle glow, a question floats upward like a dust mote rising on a warm current of starlight. How vast must the universe be? How overwhelming in its immensity, for humanity to abandon the familiar comfort of kilometers and reach for new forms of measurement? It is a quiet question, yet it echoes across the corridors of astronomy like the trailing resonance of a distant nebula. For as long as humans have watched the heavens, we have tried to trap their enormity in the small cage of our own language, carving numbers into the darkness as if they could soften the infinite. A kilometer was once a noble tool, a kind of fragile torch to bring light to the unknown. But the moment we lifted it toward the stars, it flickered, trembled, and went out. The universe was simply too large, too silent, too unconcerned with the human scale to be measured by the units we crafted for rivers and roads. When we look up at the night sky, we see distance the way a child sees the horizon. Reachable, perhaps, if only we walk long enough. But space is a different kind of country. A place where the familiar rules of intuition are not merely bent, but dissolved entirely in the dark sea between the stars. As Carl Sagan once whispered into the soft roar of the cosmos, the universe will always be much grander than anything we can imagine. And indeed it is. To understand the failure of kilometers is to understand humility. For the numbers we use on Earth crumble like sand when stretched across the orbits of planets. Imagine trying to describe the distance from the Earth to the Sun. 150 million kilometers. A number so large that it ceases to be a number at all, becoming instead a blur, a whisper, a ghostly shape our minds cannot hold. A scientist once remarked, "A number loses meaning when it refuses to fit inside the human mind." And nowhere is this more true than in the vastness of interplanetary space. So humanity did what it has always done when confronted with the ungraspable. It reached for metaphor, for simplicity, for a new anchor in the drifting dark. We created the astronomical unit, a single elegant stroke of definition, the average distance between the Earth and the Sun, a measurement not born of the human body, but of the cosmos itself. The astronomical unit became our first cosmic heartbeat, a rhythm that allowed us to step gently into a wider world. Mercury at a timid 0.4 AU, the asteroid belt stretching at 2 and 3 AU, Neptune gliding in the dark at a lonely 30 AU. Suddenly the solar system had a language that matched its own scale, and for a moment, kilometers sighed and faded into memory like a forgotten dialect of an earlier age. Yet as we moved farther out, even the AU began to stretch, thin, translucent like a thread of starlight pulled taut across unimaginable emptiness. Distances between stars were so great that even the AU, our proud new tool, became small and brittle, dissolving under the sheer magnitude of the cosmos. Light years took its place, not because we fully understood light, but because we trusted it as a constant. A companion is less than WBR, is greater than that could cross the void without tiring. As Einstein once said, the speed of light is the structure of reality itself. It became our ruler, our compass, our quiet assurance in a universe that cares nothing for our limitations. 1 light year. The distance light travels in 1 year. Nearly 10 trillion kilometers. But even this was not enough. For soon our telescopes were gazing not just at stars, but at galaxies, clusters, superclusters, filaments stretching like luminous highways across the cosmic web. A single light year became as small as a dewdrop on a drifting leaf carried across a vast ocean of space-time. And then came the ultimate question. Subtle, unsettling, whispered from the edges of philosophy and physics alike. If the universe is infinite, if its fabric stretches without boundary, then do our measurements have meaning at all? Are we mapping an endless plain with tools designed for gardens and cities, counting grains of sand on a shore that has no end? Astronomers do not deny the poignancy of this dilemma. They carry it like a quiet stone in the pocket of their thoughts. The physicist John Archibald Wheeler once wrote, "We are not just observers of the universe. We are participants in its unfolding, and our measurements are part of its story." If the universe is infinite, perhaps the point is not to contain it, but to walk within it, measuring not to define, but to understand. Because the truth is gentle and profound. Not all measurements are meant for control. Some are meant simply to help us stand in awe. The AU helps us grasp the solar system. The light year helps us sense the stars. And the parsec helps map the great spines of the cosmic web like rivers flowing through eternity. But the universe is not a straight road, not a grid, not a shape with corners and edges. It is more like a poem unfolding across time, or a song sung by galaxies drifting through the silence, or a shimmering tapestry woven from gravity and light. In such a place, measurements are less about boundaries and more about direction, less about limits and more about connection. And perhaps that is the quiet truth hiding beneath all our units and scales. The kilometer with its small earthly stride, the AU with its steady solar pulse, the light year with its sweeping cosmic sweep. They are all human attempts to touch something too large to hold, to name something that cannot be named. If the universe is infinite, then meaning does not come from the end of the path, but from the act of walking it. We measure to remind ourselves that we are here, tiny, curious, and astonishingly capable of wonder. We measure to remember that despite the cold darkness between the stars, we carry the warmth of consciousness, a small flame moving through the endless night. And so we return to the question that began this meditation. How vast must the universe be for humanity to forge new units of distance? Vast, enough that kilometers fall like petals from a tree unable to endure the cosmic wind. Vast enough that AU rise like steady lanterns across the solar sea. Vast enough that light years stretch into the deep, carrying the glow of our curiosity farther than our bodies could ever travel. In the end, perhaps the universe needs no measurement at all. But we do. For the act of measuring is the act of reaching out. And the act of reaching out is what makes us human. And if the universe truly has no end, then our search for meaning does not end either. When we speak of the solar system, we imagine a great cosmic island suspended in an ocean of unlit cold. We imagine a center, the sun, blazing like a miniature eternity. And we imagine a boundary, a final shoreline where our world of light gives way to interstellar night. But the deeper we look, the more this imagined frontier dissolves, slipping through our fingers like grains of cosmic sand. Astronomer Carl Sagan once said that science is a candle in the dark. Yet even he admitted that darkness itself has its own geography, its own quiet shape. And so we find ourselves drifting outward from the familiar planets, beyond Mars, beyond Jupiter's swirling storms, beyond Neptune's trembling blue rim, searching for the place where the solar system ends, or perhaps where our imagination insists it must end. The truth is softer, stranger, more elusive. For there is no wall of stone, no cosmic fence, no signpost written in solar wind declaring you are now leaving the solar system. Instead, there is a vast and trembling threshold called the heliosphere, a bubble inflated not by matter but by the breath of the sun. This breath, the solar wind, streams outward in all directions, carrying with it charged particles that race into the dark like messengers running until their strength fails. When this wind finally weakens against the thin press of interstellar gas, it forms a boundary not unlike the surface of a soap bubble, soft, invisible, and constantly changing. NASA astronomer Merav Ofer once described the heliosphere as a living thing, a shape sculpted by forces we cannot see. But is this truly the edge? The final edge? Voyager 1 and Voyager 2 were the first to touch this frontier, and their instruments recorded a subtle trembling, a shift in the density of particles, as if they had passed from one type of cosmic air into another. Yet the change was gentle, soft, more like crossing a quiet fog bank than stepping through a doorway. Even now, those spacecraft drift through interstellar space, but they still carry echoes of sunlight, bound to the memory of home. And, beyond the heliosphere, farther still, lies the Oort cloud, a sphere of ancient icy bodies, frozen fragments left over from the dawn of the solar system, each one smaller than a forgotten mountain, each one drifting in a darkness so complete it feels almost sacred. The Dutch astronomer Jan Oort imagined this cloud not as a structure with a surface, but as a region where comets sleep for millions of years, waiting for the faintest tug of gravity to call them inward again. But here a deeper question arises. If the Oort cloud fades into the interstellar medium with no clear boundary, if its edges are statistical, porous, undefined, then can we truly call it a frontier? Or is it merely the last whisper of the sun's dominion, the faintest remnant of a gravitational voice reaching out across half a light year? What does a boundary mean in a universe that may have no boundary? The more we follow this question, the more it becomes a meditation rather than a measurement. For Rhea is a human need, a desire to place a frame around the infinite, to say here is order, here is structure, here is where my map ends. But the cosmos is under no obligation to match our expectations. As physicist Richard Feynman once said, the universe is not required to be in perfect harmony with human ambition. We often imagine interstellar space as empty, a silent desert. Yet it contains whispers of hydrogen, drifting ions, magnetic fields that bend like strands of invisible silk, and radiation born from ancient supernovae. This faint mixture pushes gently against the heliosphere, reshaping it into a teardrop or a croissant, or perhaps a flower petal drifting on a cosmic tide. Scientists still debate the exact shape, for the universe hides its geometry behind layers of subtle force. But even this conceptual boundary is not final. For gravity reaches farther than light, farther than wind, farther than the memories we can measure. The sun's gravity holds influence far beyond the heliopause, far beyond the Oort cloud, its pull extending like an ancient chant into the night. But even this influence has no sharp cutoff. It merely fades, weakens, dissolves into the background gravity of the Milky Way. So again we return to the question, does the solar system truly have a Rhea? If we define it by the solar wind, then the edge is the heliopause. If we define it by comets, then the edge is the Oort cloud. If we define it by gravity, then the edge dissolves into the fabric of the galaxy. Each definition is true and yet incomplete, like three poets describing the same horizon from different shores. And in this unfinished geometry, in this gentle confusion, lies the deeper beauty of the cosmos. Boundaries are not walls. They are gradients, transitions, slow dissolves between realms. In the language of astrophysics, edges are not lines. They are probabilities. Consider this. When Voyager crossed the heliopause, no bell rang, no alarm sounded. No cosmic announcement declared that humanity had left home. Instead, there was only a change in particle density, a new texture in the quiet around it, like moving from a warm breeze into a still winter room. The boundary existed, but it was subtle, soft, poetic. Perhaps the universe is telling us something in this softness. Perhaps boundaries are illusions born from our need for structure, from our longing to measure the immeasurable. In a universe without walls, without edges, without a final outer rim, we are invited not to divide, but to flow. As astrophysicist Katie Mack wrote, "The edge of the universe is not a place you go to. It is a limit to what you can see." If that is true for the whole cosmos, why would it not also be true for our sun's domain? Maybe the idea of a Rhea is less a physical truth and more a reflection of our human instinct to draw circles around mysteries, to give ourselves a sense of orientation amidst the vastness. The solar system is not a box, not a sphere, not a territory with a neat perimeter. It is a gradient of influence, a whisper of forces, a slowly fading glow merging into the larger glow of the galaxy. If we could stand a light year away and look back, there would be no visible shell, no shimmering dome, only a faint region where comets sleep. And beyond it, the soft gravity of countless stars blending into one another. And so the question changes, grows, deepens. Instead of asking where the solar system ends, perhaps we should ask where the Milky Way begins. Instead of seeking a boundary in space, perhaps we should seek a boundary in understanding. Instead of searching for an ending, perhaps we should accept the gentle truth whispered by the cosmos. The universe flows, and we flow within it. In this flowing, Rhea becomes a conversation rather than a line, a transition rather than a rule. The heliosphere breathes, the Oort cloud dreams, the interstellar medium hums softly like a sleeping sea. And we, the observers, drift among these shifting borders, learning, listening, reaching. There may never be a final edge, a last outpost, a cosmic fence where the solar system stops and the galaxy begins. But perhaps that is the point. As physicist Brian Greene once said, the universe is under no obligation to make sense to us. Yet in its refusal to draw hard boundaries, it reveals something gentle, something profoundly moving. It invites us to imagine a cosmos not as a collection of boxes, but as a single unfolding breath. And in that breath, every edge is simply the beginning of something greater. In the vast quiet of the cosmos, where darkness stretches like a silk tapestry unrolled across eternity, there lingers a question older than the first starlight and quieter than the breath of a sleeping world. Is space truly empty? Or does the void carry hidden rivers that slip past silently, shaping our solar system in ways we barely comprehend? For centuries we imagined the universe as a cold vacuum, an endless desert devoid of presence or movement. Yet as the instruments of human curiosity sharpened, the silence began to unravel, revealing currents and tides flowing through what we once called nothingness. The physicist John Wheeler once whispered a sentiment that now feels prophetic. Empty space is not empty at all. And indeed, the deeper we look, the more the void behaves like a subtle ocean, stirred by forces older than the planets themselves. Consider the solar wind, that invisible breath from the sun slipping outward in every direction. It is not a metaphorical wind, but a real one, a stream of charged particles born in the furnace of the solar corona, racing outward at hundreds of kilometers each second. They whisper across the planetary orbits and comb the tails of comets into gleaming spears that always point away from their fiery source. An early puzzle for astronomers was this uncanny precision, this unwavering orientation, as if the sun were exhaling forcefully across the kingdom of its planets. But the sun is not simply breathing, it is sculpting. To understand this, sculpting, one must enter the realm of plasma, the fourth state of matter, a state so common in the universe yet so alien to earthbound intuition. Plasma is matter stripped of its electrons, charged, restless, stirred into motion by magnetic fields that twist and snap like serpents of fire around the solar surface. Each flare, each loop. Each eruption flinging particles into space is a reminder that the sun is not a lantern but a living engine, humming with magnetic storms. Magnetic fields are the scaffolding of the universe, astrophysicist Eugene Parker once said. And in the sun's case, this scaffolding becomes the architecture of a vast unseen ocean surrounding us. Those particles the sun unleashes do not merely drift. They are swept along the sun's magnetic lines, spiraling outward in elegant helices. This union between plasma and magnetism creates the solar wind. A wind with no scent or sound, yet powerful enough to shape the boundaries of our cosmic home. As the wind streams outward, it eventually collides with the thin haze of matter that exists between the stars, the interstellar medium. Though we once assumed interstellar space to be perfectly empty, it is not. It holds atoms and dust and relic particles, drifting since the early ages of the galaxy. Against this interstellar presence, the solar wind pushes, slows, and finally forms a bubble. A shimmering shell of magnetic pressure called the heliosphere. The heliosphere is our planetary cocoon, an invisible shield that deflects cosmic rays and shelters the planets from the harshest storms of the galaxy. To imagine it is to picture a boat sailing across a dark sea, its hull creating a bow wave as it moves. So too does the heliosphere carve its shape through the interstellar medium, stretching like a teardrop through the galactic currents. This imagery leads us to another question that lingers like a soft echo beneath the stars. If space is filled with such currents, if magnetic tides and plasma winds weave through the darkness like ancient rivers, then is space truly empty? Or is emptiness itself an illusion born from human eyes that cannot yet see the subtle worlds within the void? Carl Sagan once wrote, "The universe is not obliged to make sense to us." And nowhere is that more evident than in the nature of the so-called vacuum. For the vacuum is restless, trembling with virtual particles that pop in and out of existence, vibrating with quantum probabilities. Even the quietest regions of interstellar space hold electromagnetic whispers, thermal echoes, and gravitational tides that ripple across light years. The solar wind is only the first clue, a surface ripple on a vast sea, whose depths we are only beginning to map. Beyond it, the galaxy thrums with other flows, the spiral pattern of stars migrating through arms of density waves, the drifting of interstellar clouds shepherded by magnetic fields, the galactic winds that stream from star-forming regions like great slow-moving storms. These motions suggest a universe not still but simmering, not empty but alive. If such currents exist on every scale, from solar systems to galaxies to the cosmic web itself, then the question of boundaries becomes more fragile than ever. We speak of edges, horizons, borders. Yet the cosmos may respect none of these human comforts. What does it mean to say the universe ends when its contents move like water? When gravity pulls across endless distances? When dark matter forms halos that stretch beyond the reach of starlight? Our heliosphere has a boundary, but that boundary is porous, shifting, breathing with the heartbeat of the solar cycle. The galaxy has structures, but they are gradients, not walls. Even the observable universe has a horizon, But that horizon exists only because light needs time to travel. Beyond it, the universe continues in ways we cannot yet witness. So what becomes of the idea of an ending? A final frontier? A cosmic perimeter? It dissolves like mist under the rising sun. In a universe carved by currents and invisible tides, boundaries are not lines but transitions. Not walls but whispers. The sun's wind blurs into the interstellar medium. The interstellar medium blends into the galactic sea, and galaxies themselves ride along filaments of the cosmic web that stretch farther than imagination's reach. When we view space not as a void but as an ocean, everything changes. The planets become islands. The heliosphere, a drifting ship, and our star merely one lantern in a vast archipelago of burning suns. And in this ocean, the winds never cease. Perhaps that is the lesson hidden within the solar wind, within the magnetic murmurs of the sun, within the trembling fields of plasma that spiral outward into the night. The universe does not sit in silence. It flows. The vacuum does not lie still. It stirs. And we, children of this quiet planet, drift upon these ancient tides whether we feel them or not. So when we ask whether space has boundaries, whether the universe ends, whether emptiness is real, we may be touching a truth too vast for words. A truth that echoes softly through the cosmic dark, telling us that nothingness is a myth, that the void is full, that the universe is a sea of invisible motion, and in that sea, we are all still learning how to float. When we drift toward the dome, sun, the radiant heart of our system, we expect truth to sharpen and clarity to rise like a dawn without clouds. Yet, with every kilometer that solar orbiter approaches its blazing surface, the world does not become clearer, but stranger, hotter, more treacherous. What we thought would be illumination becomes a shimmering mirage, a place where certainty melts like ice in a furnace. There is an ancient line by astrophysicist Eugene Parker, the pioneer of solar wind, who once said, "The sun is a violent place, and it does not apologize." As solar orbiter spirals closer, we understand what he meant not as poetry, but as a lived experience etched into the metal of the spacecraft itself. The sun, from a distance, looks serene, a golden coin in a quiet sky. But proximity strips away the illusion, revealing a surface that is not a surface, a boiling ocean of plasma, sculpted by magnetic forces that twist and snap like invisible serpents. Nothing solid holds it together. No crust. No firm boundary. Instead, a continuous storm reshapes itself every second, every breath. Giant loops of superheated plasma rise and collapse, each arc wider than Earth, each flare carrying the energy of 1 billion atomic bombs. And in this environment, solar orbiter is expected to see clearly, to measure the sun's heartbeat, to whisper its secrets back home across millions of kilometers. But truth near the sun is not given freely. It resists, warps, fractures under the violence of extreme physics. This is why solar orbiter must carry a shield, a single barrier between understanding and annihilation. Engineers call it the heat shield, but astronauts and heliophysicists often refer to it more reverently as the absolute shield. Without it, the spacecraft would be undone in seconds. At closest approach, sunlight is 13 times stronger than what touches Earth, a relentless stream of photons that could strip atoms from metal, melt circuits, and blind every sensor. The heat shield is a masterpiece of human defiance. It is built from titanium and carbon foam, wrapped in layers designed not only to endure heat, but to create a pocket of darkness behind it, a shadow in which fragile instruments may breathe, whisper, live. Solar orbiter must constantly face its shield toward the sun, like a warrior raising armor toward a dragon of light. One wrong angle, one misalignment, and the spacecraft would burst in a silent bloom of white heat, never reaching Earth again. Yet even within this shielded sanctuary, data becomes turbulent. As we approach the sun's outer atmosphere, magnetic fields twist into braids that can snap and reconnect in violent bursts. Plasma flows in unpredictable currents. Temperature gradients shift without warning, and particles move at speeds that blur the meaning of motion itself. No algorithm built on earthly logic can fully anticipate these storms. The closer we get, the more chaotic the truth becomes. It is a cosmic irony that distance offers simplicity, while proximity births confusion. NASA heliophysicist Nicola Fox once remarked, "The sun is the only star we can touch." And yet the closer we go, the less it behaves like a star we understand. This is not a failure of science, but a revelation of scale. At great distances, the sun behaves like an idealized sphere, a luminous constant in our equations. But as we move inward, our models unravel, because the sun is not a point of light, not a perfect orb, but a living cauldron of fluid dynamics and magnetism. The solar orbiter encounters regions where data spikes into noise, where magnetic polarity flips without warning, where shock waves ripple outward like invisible tsunamis. Instruments that should agree begin to argue. Sensors reading the same environment diverge by wide margins. The sun is not lying. It is merely more complex than the mathematics we bring to it. The deeper truth behind the chaos may extend far beyond this single star. As solar orbiter slips through the inner heliosphere, we are reminded of something profound. The sun has no sharp edges, no defined boundary, no center that behaves like a geometric center. Its influence blends seamlessly with interplanetary space, and with the invisible currents of the heliosphere that stretch billions of kilometers outward. If even our star lacks a clean center, what does that say about the universe itself? Cosmology has long wrestled with the illusion of structure, the comfort of edges, the desire for a center from which everything else may be measured. But the sun number set in the vast cosmic C number reminds us that astrophysical objects are rarely as simple as textbooks suggest. As physicist Stephen Hawking once observed, "The universe is under no obligation to make sense to you." His words echo softly when we imagine the solar orbiter navigating a domain where physics grows wild and untamed. If we cannot find a stable center in a single star, can we expect to find one in a universe of 2 trillion galaxies? The concept of a universal center has been abandoned for decades, replaced by the cosmological principle, which states that on large scales, every direction is the same. Every place is as ordinary as any other. Yet the storms around the sun challenge our intuition. Perhaps our desire for a center is a human instinct, not a cosmic truth. Solar orbiter swoops through regions where gravity, magnetism, and plasma collide in dances older than planets. These motions do not originate from a single nucleus, but from fluid interactions distributed across millions of cubic kilometers. The sun's center is a concept useful in theory, yet impossible to witness in the violent ballet of its outer layers. Likewise, a universal boundary is a comfort for the mind, but perhaps no more real than the imaginary lines on a map drawn over a drifting ocean. The idea that the universe has no edge is not simply philosophical. It is mathematically consistent with everything we know. The sun, with its diffuse corona blended into the solar wind, is a miniature version of this same cosmic principle. The absence of solid boundaries does not imply chaos, but continuity. Solar orbiter's journey thus becomes a meditation on scale. At one scale, the sun is a bright disk, stable, predictable. At another, it is a fractal tempest where laws of physics twist into unexpected shapes. At a deeper scale still, it becomes a clue to the nature of the cosmos itself. The closer we look, the less defined things become, and the more they dissolve into gradients. The farther we step back, the more they solidify into patterns, a reminder that truth is entangled with perspective. Solar orbiter teaches us that danger and knowledge often share a border so thin it vanishes when touched. Its instruments strain against a domain where understanding burns as fiercely as the star they seek to decode. And perhaps the greatest revelation is this: if the sun has no clear boundary, if its truth dissolves into turbulence the closer we draw, then maybe the universe too is a boundless field, without walls, without edges, without a privileged center. We are not looking inward toward an ultimate truth, but outward into an ever-expanding horizon. Solar orbiter orbits a question as old as fire, yet newly sharpened by modern eyes. What if the universe has no center because it needs none, and no edge because it grows beyond everything we can imagine, unfolding like a dawn that never ends? And in that silent realization, as the spacecraft glides through the solar winds, shield glowing, sensors trembling, we begin to sense the truth Parker foresaw and Hawking whispered. The universe is vast, restless, and profoundly indifferent. Yet in its indifference, it gifts us wonder. And wonder, in the end, is the closest thing we have to understanding anything at all. When we slip quietly beyond the warm halo of our sun, drifting past the slow breath of the heliosphere, the universe begins to unfold in a way that feels almost impossible to measure. Out there, in the dim pasture between stars, Distance is no longer something we can hold in our hands. No longer a line we draw across a map. It becomes a horizon that deepens as we approach it, like a mirage made of starlight. And the farther we step from the sun's familiar gravity, the more the universe stretches not outward but inward, into us, reminding us that scale is something our minds adopt for survival, not something the cosmos has ever agreed to obey. There is a silence in interstellar space that does not feel empty, but ancient. A silence so complete that even thought seems to echo, returning with softened edges. As we move beyond the last faint snow of icy bodies in the Oort cloud, our solar system shrinks behind us like a lantern left on a distant shore. The sun, once a roaring presence dominating every sky we have ever known, becomes just another star, smaller than the smallest flame when held at arm's length. And with that shrinking, a revelation arises. If our mighty sun is only one trembling spark among hundreds of billions, then what does that say about our place in the vast unfolding tapestry of the Milky Way? Generations before us looked up and believed the Milky Way was everything that existed. An entire universe arched above them with gentle inevitability. To them, it was not a galaxy, not a single island of stars among countless others, but the whole cosmic sea itself. How could it have been otherwise, when the night sky offered no evidence to contradict the grandeur of that sweeping river of light? As the physicist Arthur Eddington once wrote, "Not only is the universe stranger than we imagine, it is stranger than we can imagine." And before modern tools pierced the heavens, imagination was the only available instrument, one prone to both beauty and illusion. For centuries, astronomers debated the nature of the mysterious fuzzy clouds they saw through early telescopes. These nebulous smudges, flickering at the edge of vision, seemed too large to be stars, too shapeless to be anything familiar. Some insisted they were island universes far beyond the Milky Way, while others argued they belonged to our own stellar neighborhood. The debate swelled and retreated like a tide, unresolved yet persistent. Until one night, a century ago, a young astronomer named Edwin Hubble pointed his telescope at a particular cloud in Andromeda and found something extraordinary. Embedded within that ghostly swirl, he detected a Cepheid variable star, a star whose rhythm was as steady as a cosmic heartbeat, offering a predictable pattern that allowed distance to be measured with astonishing accuracy. Henrietta Swan Leavitt, the brilliant mind who discovered the relationship between brightness and pulsation in Cepheids, had handed astronomy a ruler capable of spanning galaxies. Hubble used her discovery, and in that moment he realized Andromeda was far too distant to belong to the Milky Way. It was an entire galaxy of its own, a colossal congregation of stars drifting millions of light-years away. That revelation struck like a quiet explosion. For the first time in human history, we understood that our galaxy was not the universe, but merely one archipelago in an ocean of unimaginable breadth. The philosopher Bertrand Russell once said, "The universe may be vast and cold, but there is no reason to think it has ever been fully mapped by human thought." And in the wake of Hubble's discovery, this sentiment rang truer than ever. What had once seemed like the boundary of everything was merely the first ripple in a widening sea. Andromeda's confirmation as a galaxy was the first blow to the illusion of a finite cosmos, the first fracture in the shell of human certainty. It revealed not just the existence of other galaxies, but the possibility that galaxies might be countless, scattered through space like grains of luminous seed. With every deeper look through improved telescopes, the cosmos grew not by inches or miles, but by orders of magnitude. Hubble's observations showed the universe was expanding, a truth that shocked even Einstein, who once called his own refusal to acknowledge cosmic expansion the greatest blunder of my life. As we drift farther into intergalactic darkness, we begin to grasp a sobering truth. The solar system is small, the galaxy vast, and the universe almost unreal in scale. To leave the solar system is to shed the comforting illusion of proximity. To recognize that the nearest star system is so distant that even light, the fastest traveler in existence, needs more than 4 years to reach it. And beyond that, countless stars flicker in hushed anticipation, each one a sun, each one wrapped in its own retinue of worlds. When we zoom out farther still, the Milky Way unfolds like a spiral lantern. 200 billion stars swirling in a dance too slow for any human eye to witness, yet too grand to ever be forgotten. The mind strains against this immensity, trying to bind it into human terms. But the universe does not answer to human terms, and scale becomes a kind of poetry, a metaphor for the humility demanded of anyone who dares to contemplate it. Beyond the galaxy, we encounter the local group, a family of more than 50 galaxies drifting together like a loose constellation of drifting islands. And beyond that, the cosmic web stretches across the universe, a lattice of galaxies arranged not randomly but in vast filaments and shimmering clusters. The astrophysicist Carl Sagan once murmured, "Somewhere, something incredible is waiting to be known." And indeed, the universe seems to whisper new astonishments with every step we take outward. Leaving the solar system is not merely a journey of distance. It is a journey of revelation. Each new scale shatters the scale before it. Each discovery stretches the boundary of the possible. As we move outward like slow travelers drifting on an unseen current, we begin to understand why earlier generations believed the Milky Way was everything. Their universe was bounded by the limits of their instruments, and within those limits, the galaxy was indeed infinite. Today, our instruments are sharper, our reach farther, yet the horizon remains elusive. Because every time we believe we've touched the edge of the universe expands behind our backs. Every boundary we draw is erased by the next discovery. Every certainty dissolves into a more intricate wonder. This is why leaving the solar system changes everything. It is not only the beginning of interstellar travel, but the beginning of a new kind of humility. To gaze into the darkness and admit that we still know almost nothing. And perhaps that is the lesson the cosmos has been offering since the first human lifted their eyes to the stars. That scale is fluid. Boundaries are illusions. And the universe is not merely larger than we think, but larger than we can think. When we speak of stars, we often speak of brilliance and fire and distances so vast that human language folds in on itself. Yet sometimes, the most luminous revelations come not from the stars but from the quiet souls who patiently read their flickers. Souls who sift through darkness with nothing more than persistence and a fragile hope that meaning might rise from the cosmic grain. Henrietta Swan Leavitt was such a soul, a woman almost invisible in her own time, tucked away in a small room at the Harvard College Observatory, surrounded not by glory but by stacks of photographic plates that shimmered faintly when tilted toward the light. She worked in silence, nameless to the world, yet holding in her hands what Richard Feynman once called the key to the cosmos. Night after night she peered into these fragile glass windows of the universe, each plate an imprint of stars whose light had traveled across centuries to reach her. They were grainy, imperfect. Some barely more than pale dust, specks scattered on blackness. But Leavitt saw something others had overlooked, something subtle yet rhythmic, the slow breathing of a dying and reborn light. She noticed that certain stars brightened and dimmed in cycles so steady they might have been the heartbeat of the heavens. These were Cepheid variables, stars whose shimmering pulse echoed with cosmic truth. Her colleagues, mostly men, assumed this work of cataloguing and measuring was mechanical, trivial. But Leavitt looked deeper, as though she sensed that beneath these flickers lay a language that had not yet been decoded. With patience. Carl Sagan once said, "The universe reveals itself." And that is exactly what unfolded under her quiet gaze. She began to track each star's rhythm, comparing brightness and period, noting how long each one took to complete a cycle from dimming to flourishing and back again. Over thousands of measurements, something astonishing emerged, a pattern so elegant it felt almost alive. The longer the Cepheid took to pulse, the brighter it truly was. Not brighter in appearance, but brighter in essence. Brighter in a way that transcended distance and dust and the distortions of space. This discovery rippled outward like a whisper carried across a still lake, transforming from observation into revelation. For if the intrinsic brightness of a Cepheid was always tied to its period, then its observed faintness could tell us exactly how far away it was. It was as if the universe had been speaking in code and Henrietta Leavitt had just given humanity the cipher. Edwin Hubble would later build an empire of cosmology upon her insight, using Cepheids to determine that the Andromeda Nebula was not a small neighbor but an entire galaxy separated from us by more than 2 million light-years. Leavitt's work, Hubble said, has made all other work possible. And so the universe, which for centuries had been imagined as a single shimmering island, suddenly expanded beyond imagining. A boundary dissolved, a horizon fell away, and we were left standing in front of a sea so vast that even the bravest minds trembled at its edge. Before Leavitt, we could describe the stars, but not reach them. Without distance, everything remained locked in a two-dimensional sky, flat, mysterious. But with her discovery, the cosmos rose into depth, into structure, into a three-dimensional cathedral of unimaginable scale. Measuring distance is not merely about numbers. It is about orientation, about knowing where we stand in a universe that does not offer us a map. As astrophysicist Vera Rubin once said, "We live in a universe we cannot easily sense." But Levitt gave us a way to sense it, not through devices, but through the rhythm of stars themselves. Imagine the night sky before her discovery, a tapestry of scattered lights whose proximity or remoteness we could only guess. Then imagine the sky afterward, transformed into a vast landscape with hills and valleys of light, where galaxies towered like distant mountains and nebulas drifted like clouds across cosmic plains. Her work allowed us to step beyond the illusion that all stars sit upon the same black canvas, revealing instead that each glows from a different corner of a universe far deeper than we had dared to consider. And in this illumination, something profoundly human unfolded. With distance came humility, for we discovered our smallness. With distance came awe, for we glimpsed the architecture of the infinite. With distance came belonging, for by measuring where the stars were, we learned where we were. Henrietta Leavitt never saw herself as a titan of astronomy, never imagined her quiet nights bent over glass plates would echo across the centuries. But that is the nature of cosmic truth. It often arrives softly, hidden within the hands of those the world has overlooked. In a universe without obvious borders, distance becomes the only compass we possess. And Cepheid variables, with their slow, golden breathing, have become the lighthouses that guide us across the intergalactic sea. Their pulses are time kept in light, their rhythms the steady thrum of celestial hearts. They stand as bridges between the known and unknown, between the fragile world beneath our feet and the unreachable shores of galaxies that shimmer like frost on the edge of eternity. Scientists still describe Leavitt's insight with reverence, calling it one of the most important steps in the history of astronomy. And it was. Because without her, the universe would remain a flat map, a beautiful illusion, a sky painted with lights we could admire, but never truly place. With her, the universe gained dimension, gained scale, gained the possibility of infinity expressed through the simple act of seeing a star brighten and dim with patient regularity. And so we drift now through a cosmos revealed, guided by her soft discovery, measuring not only the spaces between stars but the spaces between our own questions. Henrietta Leavitt did not merely measure light, she measured the depth of creation. And in doing so, she lifted a corner of the veil that once kept the universe small. Even today, when modern telescopes scan the deep sky and capture infant galaxies born near the dawn of time, they still rely on the same cosmic pulse she uncovered. Her insight has become the quiet heartbeat beneath nearly every cosmic distance we measure. When we speak of infinite scales, we speak of her. When we speak of unlocking the universe, we speak of her. When we speak of the moment humanity first truly sensed the size of everything around us, we speak of her. The universe is vast, but sometimes it takes a single gentle mind to show us how far it really goes. And Henrietta Leavitt, in her quiet room with her quiet stars, opened that door with nothing more than patience, wonder, and the unwavering belief that even the faintest light can reveal the shape of infinity. The night sky rises like a slow tide across the mind, filling the inner horizon with a quiet question that glows brighter the longer we hold it. How vast must a galaxy be for it to fail at holding itself together? How immense must its spiraling arms become before even gravity, that ancient sculptor of everything we know, begins to slip its grip? When we speak of the Milky Way, we often imagine a serene disk of stars rotating in elegant harmony, a cosmic mandala drifting in the darkness. Yet behind this familiar image lies a truth that humbles the most confident equations and challenges the inheritance of classical physics. At the scale of galaxies, Newton's laws become lanterns that flicker in a gathering cosmic wind. Imagine drifting above the luminous disk of the Milky Way, watching hundreds of billions of stars sweep through the void in soft arcs of light, each star like a memory moving through the dark. The whole galaxy spins so quickly that, by Newton's expectations, it should come apart like petals scattered by a silent storm. The stars at the edge are moving far too fast, faster than the visible mass can possibly restrain. A classical physicist might whisper, almost with disbelief, that the Milky Way should have flung its outer stars into deep space billions of years ago. But it has not. It remains whole, bound, coherent. Like a bird with invisible wings, a force unknown holds the structure together. It was Vera Rubin who first listened to this quiet dissonance in the mathematics and dared to consider the possibility that the universe was keeping a secret. Rubin once said, "We measure the rotation of the galaxy the same way we measure the pulse of a human heart." And something in that pulse did not make sense. Her work revealed flat rotation curves, the astonishing phenomenon that stars far from the galactic center circle at the same velocity as those far nearer. According to Newton, this should be impossible. Newton expected speeds to decline with distance, like planets orbiting a star. Instead, galaxies behaved like disks whose outer edges refused to slow down. This defiance of classical reasoning led Rubin to propose something that would reshape modern cosmology. She concluded that most of the mass of a galaxy is not visible, not luminous, not made of anything we understand. It was as if a ghostly scaffolding held the stars in place, a halo unseen yet gravitationally undeniable. She gave voice to the hidden giant we now call dark matter. And in that moment, the universe grew darker, stranger, more immense than anyone had dared to imagine. Dark matter does not shine, does not burn, does not ripple with electromagnetic signatures. It is as though it is made of silence. And yet it binds billions of stars together in sweeping spirals that take hundreds of millions of years to complete a single rotation. Fritz Zwicky once remarked, "The universe is not only stranger than we think, it is stranger than we can think." Rubin's discovery brought Zwicky's words to life, revealing that the cosmos is supported by a foundation built not of light, but of darkness. Consider the scale of the Milky Way, 100,000 light-years across, a number so vast it stretches the imagination until it thins into a whisper. The light from one side of the galaxy takes longer to cross it than Homo sapiens has existed. Our entire history, every empire, every birth and death, every forgotten dream, plays out in the time it takes a single beam of starlight to drift from one spiral arm to the other. And yet, even at such a scale, the visible mass is insufficient to explain the galaxy's structure, insufficient to maintain the balance of its rotating disk. Galactic mass models show that stars and gas clouds generate only a small fraction of the gravitational glue needed to keep the spiral arms from unfurling into the void. Something vast, cold, and unseen wraps itself around the galaxy like a cosmic cocoon, forming a halo that extends well beyond the luminous disk. Astrophysicists estimate that nearly 85% of the universe's total mass is dark matter. That means everything we see, every star, every nebula, every glowing thread stitched across the cosmic web, represents only 15% of what is truly there. The universe is built of absence, shaped by invisibility, governed by something that refuses to reveal its face. And this leads to the most haunting question of all. If most of the universe is dark matter, then where do we place the idea of a boundary? A boundary is drawn by what can be seen, traced, measured. But if the architecture of the cosmos is built mostly from what cannot be observed, what does it mean for space to have an edge? The cosmological horizon is not a wall, but a distance beyond which light has not yet reached us. Beyond that horizon, dark matter may extend forever, forming halos upon halos, structures curling through a darkness that may itself be without limit. To drift through this idea is to feel as though one is floating in a deeper ocean than any ancient mariner ever imagined. A sea without shores, without tides, without a final line where water meets air. Stephen Hawking once said, "To confine our attention to terrestrial matters would be to limit the human spirit." But the more we gaze outward, the more the universe gently reminds us that even our cosmic attention has boundaries shaped by light. What lies beyond that light may never be fully known, only inferred by the dance of galaxies and the whisper of gravity. As we move through the Milky Way in thought, we realize that its spiral arms, though radiant, are only embellishments atop a far greater mass. The visible galaxy is like a poem written on the surface of an invisible book. The true structure lies beneath, silent, formless, enfolding everything in gravitational embrace. This invisible halo is not a thin shell, but a vast region extending several 100,000 light-years in every direction, so that the Milky Way's true form is more sphere than disk. Our picture of the galaxy transforms the moment we accept that its mass extends far into the darkness. If we could see dark matter directly, the night sky would bloom with structures so immense they would make the luminous stars seem like fireflies drifting through a forest of shadows. The cosmic web would rise like a lattice of invisible rivers, guiding galaxies the way deep ocean currents guide drifting islands. And so the question returns, soft as starlight, insistent as gravity. If the Milky Way cannot hold itself together without something unseen, and if this unseen substance fills the universe, then what becomes of the notion of a cosmic boundary? Where does a galaxy end? Where does dark matter end? Where does the universe itself draw a line and say that beyond this, there is no more? Perhaps the boundary is not a place but an illusion, a story told by light. Light travels a finite distance, and so we shape our sense of the universe through what light allows us to witness. But gravity listens to mass regardless of whether it shines. And dark matter speaks to gravity alone, forming structures that do not care whether we see them or not. In this sense, the edge of the universe is not a wall, nor a horizon, nor a limit. It is a question floating like mist through the corridors of space, one that invites us deeper into mystery. The Milky Way holds because something unseen allows it to. And in that unseen substance lies the key to understanding a universe that may have no end at all. When we look at the universe through human eyes, we are seeing only a fragile sliver of its true face. Our vision is a thin window carved by evolution, tuned not for wonder, but for survival. We see the world in the narrow strip of visible light, where sunlight is gentle, green fields flourish, and skin does not burn. And yet, beyond this shimmering band of color lies an ocean of wavelengths stretching in both directions, a vast and hidden continent where the universe reveals its deeper truths. As Carl Sagan once whispered, the universe is not only stranger than we imagine, it is stranger than we can imagine. If our eyes could drift into the infrared, the night sky would transform into a glowing tapestry of warmth and breath, a universe pulsing softly like a sleeping animal. Dust clouds that look dark and silent to human sight would melt away, revealing stars being born inside cosmic cradles, their heat leaking through the veils of cold and shadow. The great nebulae would appear not as painted clouds but as rivers of thermal light, streaming and folding like silk drifting in a slow interstellar wind. The Milky Way's dusty lanes, once opaque and mysterious, would open like curtains, and behind them we would glimpse clusters and spirals and ancient suns that have been hidden from us for all of human history. To see in infrared is to learn that darkness is not the absence of light, but the absence of the right eyes to see it. Astronomer Edward Wright once said, "Infrared light is the whisper of the cosmos." It carries the heat of stars just formed, the glow of planets too cold for daylight, the faint warmth of dust drifting between stars. It is the universe breathing, exhaling slow clouds of photons across gulfs of time. And if we had evolved to see in this gentle light, perhaps we would understand that creation is not a violent flash, but a long, patient unfolding. But the universe is not only tenderness. If we leap across the spectrum into X-rays, we enter a harsher realm, a place where matter screams with unimaginable energy. Here, the centers of galaxies blaze like wounds in space, their supermassive black holes devouring gas and stars and dust. Each mouthful becomes heat, millions of degrees, erupting in jets of radiation that slice through the cosmic night. What looks calm in visible light is in truth a battlefield where gravity and matter wage endless war. X-ray eyes would show us the skeleton of the universe, the bones of clusters bound together by dark matter. In this domain, shock waves ripple through intergalactic gas. Explosions echo for millions of years. This is the violence hidden beneath beauty, the furnace beneath the silk. As astrophysicist Martin Rees wrote, "The universe is a firework display seen in slow motion. If we could see in X-rays, the night sky would never appear peaceful again. Every quiet point of light would crack open into storms of radiation. Every gentle star field would tremble with invisible fire. The calm spiral of the Milky Way would reveal its raging heart, a black hole hurling energy outward like thunder made of light. And so the question arises, if every wavelength gives us a different universe, then what is the universe truly, underneath all our limited human senses? What does it look like when seen by no single creature, no single instrument, but by the sum of all possible ways of seeing? Perhaps the universe has no single appearance at all. Perhaps it is not a picture but a symphony, each wavelength a different instrument, each revealing a separate harmony in the cosmic score. To see only visible light is to hear just the violins, gentle, human. To see infrared is to hear the cellos, warm, resonant. To see X-rays is to hear the percussion, fierce, thunderous. And the full universe is the orchestra, playing not to us, not for us, but simply because it exists. The great physicist Freeman Dyson once said, "The universe shows us different faces depending on how we look at it." And he was right. The cosmos is a shapeshifter, a master of disguise, revealing itself not through certainty but through layers. What we see is always a translation, never the original text. Invisible light. A nebula appears as a calm watercolor painted across the night. In infrared, it becomes a womb where stars ignite. In X-rays, it is a forge where atoms collide and collapse. And each version is true, yet none is complete. The universe is like a poem written in many languages, and we are forever reading only one verse. If a creature evolved under a red dwarf star, bathing constantly in infrared light, its entire concept of the cosmos would be different. If life arose in a dense nebula, seeing the faint glow of X-rays as easily as we see sunlight, its myths and science would grow from a universe of fire and turbulence. And if intelligence emerged in the cold, dark plains between galaxies, where only radio waves drift like lonely travelers, its view of existence would be slower, quieter, more ancient. Who is to say which vision is the real one? Who is to say ours is not the least accurate, the most naive? Perhaps the question itself is misguided. What does the universe really look like assumes that reality has a shape meant to be seen. That truth is an image on a cosmic canvas. But maybe the universe is not an appearance, but an experience, changing depending on the eyes that witness it. Maybe the universe looks like infrared warmth to a young star being born, like X-ray fire to a black hole consuming matter, like radio whispers to a drifting cloud of hydrogen. And to us, with our fragile eyes and our brief lives, it looks like the night sky, we know, a soft sprinkle of light across the darkness. But that is only the beginning. When we gaze upward, we are not seeing the universe as it is, but as our biology permits. The cosmos stretches far beyond our senses, far beyond our fears, far beyond our dreams. And every instrument we build, every telescope we launch, is another step toward widening that narrow keyhole through which humanity peers. What the universe truly looks like may be something no single creature can ever comprehend. A tapestry woven from wavelengths we have yet to imagine. A mosaic of energies dancing across space-time. Perhaps the true universe is too vast to fit inside any pair of eyes, too ancient to be held by any mind. But still we try, because wonder is older than fear, and curiosity is the first language of the stars. And so we continue to look, to listen, to reach. We build telescopes that see heat leaking from newborn suns, detectors that capture the wild screams of black holes, arrays that sense radio waves drifting across intergalactic deserts. With each new way of seeing, the universe grows larger, richer, stranger. And with each revelation, we are reminded that reality is not a picture to be observed, but a mystery to be entered. The universe seen through non-human eyes is not simply a different world. It is a deeper world. A world where creation and destruction flow in the same river. Where darkness holds hidden light. Where silence is filled with ancient echoes. And perhaps, if we listen closely, look patiently, breathe slowly, we will begin to understand that the universe does not hide itself from us. We merely have not learned how to see it yet. There are moments when silence seems to stretch farther than any horizon we have ever known. Moments when the vastness of space feels like a cathedral with walls made of darkness and pillars sculpted from starlight. And in that immensity we encounter a question that trembles softly at the edge of our understanding. How can sound exist in a universe that appears so breathless, so empty, so impossibly vast? Human intuition whispers that sound should die in the vacuum between stars, that waves need something solid or fluid to lean on. That silence must be the native tongue of the cosmos. And yet the universe gently contradicts us, leaving behind clues in ripples of gas, in the trembling of interstellar clouds, in the deep bass, murmurs of galaxies that breathe in rhythms older than time itself. As Carl Sagan once wrote, "Somewhere something incredible is waiting to be known." And one of those incredible truths is that the universe is not silent at all, only subtle, patient, and profoundly slow in the language it chooses to speak. To understand this cosmic whisper, we must first imagine the great stretches of space not as empty voids but as oceans made of nearly nothing. Seas of gas so thin that billions of atoms drift in a space no larger than a human breath. It seems impossible that such thinness could carry sound. Yet if we listen with instruments instead of ears, we find that these atoms still touch one another, transmitting shivers of pressure across astonishing distances. In this ethereal medium, sound becomes a traveler of unimaginable patience, taking millions of years to complete a single oscillation, as if time itself slows down to grant the wave its passage. Physicist Andrew Fabian often reminds us, the universe is a place where even a whisper can last longer than civilizations. And in that statement lies the heart of this mystery. Sound in space does not race forward as it does in air on Earth. Instead, it glides, drifting like a feather caught in an endless twilight. Every ripple must push through clouds of hydrogen and helium, grains of dust, threads of plasma that stretch between stars like luminous spider silk. These particles are few, but they are enough. And in their sparsity, the cosmos finds a way to speak. Imagine a wave traveling through a nebula the size of a solar system. Its crest and trough separated not by meters, but by light years. A single vibration, unfolding so slowly that our entire species might rise and fall before the wave completes its journey. This is sound stripped of haste. Sound stretched into the language of eternity. Yet there is another source of cosmic sound, more ancient and more terrifying than drifting clouds of gas. A source born at the edge of physics and wrapped in darkness so complete that no light escapes its embrace. The black hole. These titanic wells of gravity bend the fabric of space-time until it folds like soft cloth. And as matter spirals inward, it screams not with voice but with energy, releasing pressure waves that ripple through surrounding plasma like tremors through a cosmic sea. The waves that black holes create are slow to the point of surrealism. Their frequency so low that an entire human lifetime passes in the span of a single oscillation. When astronomers observed the supermassive black hole at the center of the Perseus cluster, they found something astonishing. A note, a real note, vibrating through intergalactic gas. A B-flat 35 octaves below the first, lowest note a human ear can detect. To make that pitch audible, we would need an organ pipe the size of a galaxy, a structure so vast that its shadow would eclipse entire clusters of stars. As Professor Fabian explained, it is the deepest note ever detected in the cosmos, a sound that has been resonating for more than 2 billion years. Think of that for a moment. A vibration born from a black hole's hunger, ringing through a nebula like the slow toll of a cosmic bell, repeating only once every 10 million years. That means that from the moment early humans first learned to control fire, until this very second, the universe has barely completed a single wave of its ancient song. Time loses meaning in these stretches, dissolving like mist under starlight. And we who measure life in decades find ourselves humbled by a voice that speaks in intervals longer than our entire species has existed. In this sense, the universe is not silent, but simply speaking in a language our ears cannot translate. A language of pressure and patience, of ripples that move as softly as breath across the surface of infinity. When we try to imagine these sounds, we must abandon every earthly notion of noise. For nothing here roars or echoes. Nothing collides or rumbles in the familiar ways of our world. Instead, the cosmos hums with a serenity untouched by urgency, a lingering vibration that feels more like memory than sound. Neil deGrasse Tyson once observed, "The universe is under no obligation to make sense to you." And perhaps this is true of its music also. A music woven not for human senses but for the slow breathing of galaxies. When black holes release their vast jets of radiation, they stir the interstellar medium with forces beyond imagination, heating gas to millions of degrees and sending out waves that travel for hundreds of thousands of light years. These waves sculpt the environment around them, compressing pockets of gas until new stars ignite, or sweeping material away to leave behind deserts of cosmic silence. The universe composes its symphonies through creation and destruction, through collapse and rebirth, through the gentle whisper of drifting atoms and the violent heartbeat of Loden Kong Lo. And so we arrive at the great paradox. The universe may seem empty, yet it sings. It may seem silent, yet it vibrates with ancient music. It may appear still, yet it pulses with rhythms too slow for our fleeting lifetimes to observe. If we could translate these cosmic vibrations into human scale, if we could speed them up until they touched the edge of hearing, the universe might sound like a choir of impossibly deep harmonies, each note shaped by the gravity of stars and the breath of nebulae. But perhaps the beauty lies not in hearing these sounds, but in knowing they exist. In accepting that the universe is always speaking, always whispering, always vibrating with the echoes of its own creation. As Stephen Hawking once said, the universe has not only a history but a music, a resonance in every particle and every galaxy. And in that realization we discover something profound. The cosmos is not a silent void but a living expanse, filled with murmurs that bridge billions of years. When we listen to the universe through the instruments we build, through telescopes and spectrometers and detectors that taste the trembling of plasma, we become part of that conversation. We become witnesses to waves that outlast continents, oscillations that began before Earth had oceans, and murmurs that will continue long after the last human voice has faded. And maybe this is the lesson hidden in the cosmic song, that even in silence there is movement, even in emptiness there is connection, even in the coldest reaches of space there is a heartbeat. For the universe does not speak in words but in waves, not in sentences but in cycles, not in stories but in resonances that stretch from one side of eternity to the other. And every so often, if we listen with eyes instead of ears, we may catch the faintest hint of that ancient music, a vibration older than galaxies, a whisper traveling through the quiet sea of the cosmos. In the quiet hours when the galaxy hums beneath our awareness, the center of the Milky Way calls to us like a distant drum whose beat travels through darkness and dust. We often imagine our home galaxy as a serene spiral suspended in a cosmic ocean. But closer to its heart, this serenity dissolves into something far more intense. A realm where the rules we trust bend under forces we cannot touch. Astronomers peer into this region with instruments tuned to wavelengths that slip through the veils of interstellar dust. And what they find defies the gentle intuitions of human thought. The stars closest to the galactic center whirl around their unseen master with velocities that make the solar system seem frozen in comparison. One star, known as S2, sweeps through its orbit at nearly 5,000 kilometers per second. To place that speed in our fragile imagination, it is more than 20 times faster than most stars elsewhere in the galaxy. Fast enough that space itself seems to recoil behind it. There is no ordinary explanation for such motion. No cluster of visible stars. No cloud of gas. No arrangement of cosmic debris capable of generating the gravitational pull required to sling massive suns into such furious orbits. Something immense must lie there. Something compact. Something whose gravity crushes any attempt at resistance. And so scientists looked for the only phenomenon in nature known to possess such power. The only thing capable of bending space-time itself like soft metal beneath an invisible hand. A supermassive black hole. The center of our galaxy is a place where Einstein's equations come alive, said Reinhard Genzel, one of the astronomers who revealed the truth of this dark core. His words linger like an echo because within that region known as Sagittarius A*, lies an object with the mass of 4 million suns pressed into a volume smaller than our solar system. It is not a star, nor a sphere, nor any form our human senses are prepared to witness. It is a boundary where time folds and space curves inward, where gravity becomes not a force but a landscape. The stars dancing around this abyss follow paths that resemble strokes of calligraphy brushed by cosmic winds, each orbit a testament to the invisible presence that anchors the Milky Way. One could imagine these stars as fireflies circling the mouth of an ancient well, their frantic loops revealing the depth of something they cannot escape. The speed at which they move is not simply impressive, it is revelatory. Only a supermassive black hole can account for such acceleration, for such obedience of matter to an unseen command. And so the question emerges like a soft pulse in the dark. What lies inside this shadowed titan? The classical description tells us nothing can escape from within its event horizon, that light itself becomes a prisoner. John Wheeler once said, "Black holes have no hair," meaning they hide every detail of their existence except mass, spin, and charge. But within this simplicity lies a profound truth, for their very presence shapes the architecture of the galaxy around them. In their silence, they sculpt billions of stars, billions of worlds, billions of forgotten histories yet to unfold. Some speak of the black hole as a monster, a devourer of time and matter. But perhaps it is closer to a heartbeat, a gravitational rhythm pulsing at the center of the Milky Way. Without it, the spiral arms might soften and disperse into the vast cosmic sea, losing the elegant sweep that shelters our fragile planet. With it, the galaxy maintains its cohesion, its identity, its delicate pattern of stars that binds us to a single celestial home. Andrea Ghez, who shared the Nobel Prize for uncovering Sagittarius A*, once said, "The universe is under no obligation to make sense to you. Yet in the motion of these stars, there is a sense of order, a clarity that emerges from the chaos. Their orbits map out a gravitational truth that no eye can see, revealing the shape of something that hides perfectly from sight. As they swing close to the black hole, space-time stretches, bends, and elongates around them. Time for these stars slows imperceptibly, yielding to the strange geometry Einstein predicted more than a century ago. Here, we confront a feeling rare in science, the recognition that what we observe is both terrifying and beautiful, both alien and deeply familiar. Because black holes are not merely celestial phenomena, they are reminders of the boundaries of thought, the places where human understanding must stretch like starlight drawn thin around gravity's edge. Standing on Earth, we cannot feel the pull of Sagittarius A*, but the galaxy around us can, and it leans into that pull with a grace beyond comprehension. Every cluster, every nebula, every drifting fragment of cosmic dust is indirectly shaped by this tidal presence. The black hole is a conductor, and the Milky Way an orchestra playing a silent symphony of gravitational resonance. And yet, for all its dominance, the black hole does not roar, does not shine, does not claim attention through violence. It sits in perfect darkness, gathering matter that dares come too close, whispering its influence across 50,000 light-years. There is a paradox in this, that something so quiet can shape something so immense. Carl Sagan once reflected, "Somewhere something incredible is waiting to be known." Perhaps Sagittarius A Times is that place. A cosmic book whose pages cannot be opened but whose gravity tells the story anyway. And so we ask again, what could bend space and time at the center of the Milky Way? What could accelerate stars to velocities that defy all common sense? What could hold a galaxy of hundreds of billions of suns in its invisible embrace? The answer remains the same. A supermassive black hole of 4 million solar masses. The dark heart that anchors our spiral home. Yet as we meditate on this truth, another question blooms quietly. Does the black hole hold the galaxy together? Or does the galaxy cradle the black hole? Perhaps neither. Perhaps both. In cosmic time, the distinction between holder and held dissolves like mist in starlight. And in that dissolution, we glimpse something deeper. The universe is not a static machine but a breathing organism, and black holes are its organs of transformation. At the center of the Milky Way, the supermassive black hole performs its quiet duty, shaping the galaxy not through force alone, but through the geometry of reality itself. We exist in the fringes of its influence, far from the wild dance of the inner stars, but still held in the spiral arms that its gravity helps define. And as we drift through our small corner of this vast structure, it is humbling to remember that our entire world, our past, our future, orbits quietly within a galaxy shaped by something we cannot see. Something that bends space-time, commands the motion of suns, and yet remains invisible. Something ancient, silent, and immeasurably powerful. A reminder, in the soft voice of the cosmos, that reality is always deeper than the light that reaches our eyes. And so the center of the Milky Way continues its ceaseless Shen dance, a dance choreographed by gravity's most enigmatic form. A dance we can observe but never join. The stars will keep circling, the darkness will keep shaping, and we, tiny beings on a distant world, will keep wondering. For in that wondering, we find our place in the galaxy. Not at the center, but in the questions that guide us toward it. When we drift far beyond the warmth of our home star, beyond the delicate spirals of our Milky Way, a quiet truth begins to reveal itself. Galaxies do not wander alone. Even in the vastest reaches of the cosmic ocean, they move like ancient caravans, following invisible roads carved into the fabric of space-time. And as we float here in this imagined silence, listening to the soft hum of the universe, we begin to wonder why. In a cosmos so immense and seemingly chaotic, these islands of stars gather together as if obeying a hidden choreography. Gravity whispers the first clue, not as a force that pulls, but as a curvature that invites, shaping the motion of galaxies the way a riverbed shapes the flow of water. Einstein once said that gravity is the shape of space-time telling matter how to move. And in this gentle phrasing lies the quiet secret of cosmic companionship. Matter is never truly isolated. It bends the universe around itself, creating valleys in which other matter slowly descends, falling not with violence, but with the grace of drifting snowflakes over millennia. So galaxies form groups, then clusters, then superclusters stretching across incomprehensible distances, each one an eddy in the grand current of cosmic evolution. As astrophysicist Margaret Geller once reflected, we are beginning to see the universe as a web of matter woven together by gravity's ancient hand. It is this web that prevents galaxies from escaping into true solitude, binding them as gently and inevitably as the tides bind the seas to the moon. When we speak of Andromeda rushing toward the Milky Way, we are not witnessing a cosmic accident. We are observing the quiet pull of a deeper structure, a structure our ancestors could not imagine, yet felt in the dim stories they whispered to the stars. Andromeda is falling toward us at 300 kilometers per second, not because she is wild, but because the invisible halo of dark matter around both galaxies has intertwined their fates. The Milky Way and Andromeda are like two dancers in an infinite ballroom, each step drawing them closer through the soft creaking of gravity. Dark matter itself remains unseen, yet it shapes nearly everything we see, forming scaffolds upon which galaxies cling. Vera Rubin once said, "What you see in the sky is only the frost on a cosmic ocean of matter." And as we listen to her quiet brilliance, we understand why galaxies cluster. They are not drifting in emptiness. They are floating in a sea whose currents we are only beginning to map. Look deeper into the night sky, into the faint filaments connecting clusters across hundreds of millions of light years, and you will see patterns too vast for randomness. The cosmic web stretches like the roots of a titanic tree, branching and rebranching through eternity, each filament glowing faintly with galaxies that find comfort in each other's gravity. Some astronomers argue that this grand arrangement suggests a universe sculpted by initial conditions, imprinted moments after the Big Bang, fluctuations in density that grew slowly under the patient pull of gravity. Others suggest that perhaps the universe is not as random as we once thought. That structure is a natural consequence of time, mass, and the irresistible attraction between them. When we consider the impending merger of Andromeda and the Milky Way, it is tempting to imagine destruction. Stars colliding, systems shattering. Yet the truth is softer, more meditative, more like the gentle blending of two cosmic clouds. Most stars will pass by each other like ghosts, their orbits shifting, their paths rewriting themselves in slow, stunning arcs. The night sky of some future civilization, if one exists, will bloom with unfamiliar shapes, and the merged galaxy will carry a new name. All the while, the universe continues to expand. Yet within this expansion, local islands of gravity remain tightly bound, refusing to drift apart. This alone suggests that our cosmic environment is not chaotic, not careless, but textured with order, quiet patterns, and delicate harmonies. As cosmologist Joseph Silk once mused, structure is the universe remembering itself. And perhaps that is what these clusters and superclusters truly are. Memories, echoes, the residue of forces older than the first star. So we return to the question that brought us here. Why do galaxies not travel alone? Because solitude is not written into the laws of the process, cosmos. Because gravity gathers what is scattered. Because matter bends space in ways that invite companionship. The universe itself seems to prefer connection, prefers the slow assembling of stars into families, galaxies into communities, clusters into vast, shimmering continents of light. As we drift back toward our own tiny corner of this immeasurable sea, we feel a tender humility blooming in the quiet edges of the mind. For in a universe where even galaxies cling to each other for billions of years, perhaps we too are meant to seek connection, not isolation. And with that thought, we return to the darkened sky, watching the slow ballet of the Milky Way and Andromeda, moving toward one another through the silence, reminding us that nothing in this universe truly travels alone. In the drifting quiet of the cosmos, where galaxies bloom like slow, unfurling flowers of light, there is a place whose very existence seems to whisper that the universe is far more organized than the human mind can comprehend. Laniakea, the immense heaven, the supercluster that cradles our Milky Way in its vast gravitational embrace, stretches across 500 million light-years like a cosmic river delta carved not by water, but by gravity itself. When I think of Laniakea, I imagine a great tide of stars flowing in silence, drifting with ancient purpose, moving not randomly but as if responding to a hidden choreography etched into the fabric of space-time. The astronomer Margaret Geller once said that the universe is an artful universe, and nowhere is that art more visible than in the subtle dance of galaxies across this supercluster. When scientists first traced the motions of thousands of galaxies, plotting their velocities like the strokes of a vast cosmic calligraphy, something astonishing emerged from the noise. The galaxies were not scattering in chaotic directions, but flowing in converging streams, streams that resembled rivers on a planetary landscape. It was as though gravity had gathered them into currents, whispering to them from across unimaginable distances, guiding their paths toward a single mysterious destination. The human heart knows rivers, knows the soft pull of currents, the way water shapes a world not by force, but by patience. So when astronomers speak of galaxies drifting like streams, something deep inside us responds. These currents are not made of water, but of stars scattered across millions of light years. Yet the metaphor feels strangely natural, perhaps because the universe itself seems to prefer patterns that echo through all scales. The physicist John Wheeler once remarked that behind it all is surely an idea so simple, so beautiful, that when we grasp it, we will all say to each other, "How could it have been otherwise?" Laniakea feels like a hint of that simple and beautiful idea. But if these galaxies are the rivers, where do they flow? What is the sea that calls them? In the heart of this colossal structure lies a gravitational anomaly known as the Great Attractor, a region whose pull is so powerful that it draws entire clusters of galaxies toward it at tremendous speeds. And yet, for decades we could not see it. Like a shadow behind a veil, it hid from our telescopes, concealed by the thick dust and stars of the Milky Way's galactic plane. Astronomers called this the zone of avoidance, an area where observation was nearly impossible. It is a humbling reminder that even with the finest instruments, the universe still keeps secrets not through malice, but through the sheer complexity of its architecture. When scientists finally glimpsed fragments of the Great Attractor, they realized it was not a single object but a vast concentration of mass. A gravitational basin sculpted by clusters and dark matter, influencing galaxies across hundreds of millions of light-years. The cosmologist Brent Tully described it as a gravitational landscape, and perhaps that is the most evocative way to imagine it. Not as a point, but as a valley in the fabric of the universe, pulling the rivers of galaxies toward it. Yet the Great Attractor is only part of the story, for beyond it lies the Shapley supercluster, even more massive. As if the universe keeps revealing deeper and deeper layers of its own gravitational architecture. This suggests a profound possibility, that the cosmos is not a chaotic scattering of galaxies, but a woven tapestry, a network of filaments, voids, and superclusters arranged in patterns that mimic the neural structure of a brain. When cosmologists map these filaments across billions of light-years, the resemblance to biological networks is staggering, hinting that the universe organizes itself in ways that echo the very structure of consciousness. The astrophysicist Franco Vazza once noted that the cosmic web and the brain show comparable levels of complexity and self-organization. If this is true, then Laniakea is not merely a supercluster. It is a living thread in a cosmic nervous system, a region where galaxies follow gravitational pathways with the same inevitability that thoughts follow neural pathways. And if galaxies move like rivers, then perhaps the entire universe is a kind of ocean, shaping itself in ways we are only beginning to perceive. What does Laniakea reveal about a universe without boundaries? It shows us that structure exists far beyond the scale of galaxies, that gravity can shape order across 500 million light-years, and that patterns emerge even where chaos seems inevitable. It suggests that the universe may not simply expand into emptiness, but organize itself into webs of unimaginable scale. It reminds us that boundaries are often illusions, born not from the cosmos but from the limitations of human intuition. The poet Robinson Jeffers wrote that the universe is one being. Everything is connected, and nothing goes away. Laniakea may be the most magnificent scientific echo of that ancient sentiment. And so we drift through this immense heaven, carried along by the same currents that guide entire galaxies, feeling the soft gravity of understanding pull us towards something larger, something older, something woven into the quiet depths of space-time itself. In the end, Laniakea teaches us that the universe is not merely expanding, but unfolding, not merely moving, but flowing, and that perhaps, somewhere in the ebb and tide of galaxies, we may glimpse the first hints of a universe that organizes itself far beyond the reach of the human mind. When a principle that once held the universe together begins to tremble, something inside us trembles with it. For generations we looked into the darkness and believed that beyond a certain scale the cosmos must smooth itself out, that its galaxies and voids and rivers of light would dissolve into uniformity like mist under a rising sun. This was the cosmological principle, the quiet assumption that at the grandest distances the universe is essentially the same everywhere. It was a comforting idea, a mathematical lullaby, whispering that despite its vastness, the cosmos obeys a simple order. But then came the giant arc, a structure so large that it stretches nearly 3 billion light-years across the darkness. a bow of galaxies bending through time and space. It appeared like a scar across the sky, a reminder that nature does not always respect the clean rules we write for it. When the researchers revealed it, the scientific world inhaled sharply. If this holds up, it would challenge our understanding of the universe at the most fundamental level, said Dr. Alexia Lopez. Her voice carried the same mixture of awe and disbelief that ancient astronomers must have felt when they first realized the Milky Way was just one galaxy among countless others. Beyond the giant arc lies another giant, older in discovery, but no less disturbing. The Hercules Borealis Great Wall, a titanic weave of galaxies so immense that it spans nearly 10 billion light-years. To speak of such scales is to stretch human language until it thins like cosmic dust. To imagine structures so large that light itself needs epochs to cross them. But the real question is not their size. It is their audacity. They defy the expected limits, ignoring the theoretical ceiling set by our models of cosmic formation. As cosmologist Ethan Siegel once remarked, if these structures are real, then the universe is telling us it has never read our textbooks. In the gentle currents of deep space, galaxies usually form clusters. Clusters gather into filaments, and filaments thread across the cosmic web like luminous nerves in a sleeping giant. But those threads should not clump into walls that stretch across a measurable fraction of the observable cosmos. Gravity simply should not have enough time, enough reach, enough subtle pull to arrange matter on such unfathomable scales. Yet here they are. Walls and arcs and unimaginable assemblies of starlight, challenging the very symmetry we believed the universe possessed. And so we must return to the principle we once held sacred. The idea that the universe is isotropic and homogeneous at the largest distances. If such megastructures are not rare illusions, not misinterpretations produced by incomplete data, then perhaps the foundation of cosmology itself is shifting under our feet. What if the universe is not smooth, not even, not symmetrical on the scales we assumed? What if it is textured like ancient stone, rough in places, patterned by events older and deeper than our theories allow? The whispers of dark energy, the uneven distribution of galaxies, the discovery of immense voids and superclusters, all suggest a cosmos that may be far more wild than the models born in the 20th century. Scientists do not speak of these things lightly, nor with the certainty of mystics. They speak with caution, with humility, with an awareness that the universe has humbled every generation before them. As Stephen Hawking once said, "The greatest enemy of knowledge is not ignorance. It is the illusion of knowledge." So what happens when that illusion begins to fade? When the boundaries blur and the quiet assumptions evaporate like morning frost? Perhaps nothing changes immediately. The stars still burn. The galaxies still drift. The cosmic microwave background still hums its ancient song. But inside the human mind, something vital awakens. A sense that our cosmic story is not yet settled, that the narrative of creation is still being written by forces unfolding in the silent abyss. Imagine drifting through the dark tapestry of space, passing through the shimmering threads of the cosmic web, watching the giant arc curve like a celestial riverbank. Its light arrives to us from billions of years ago, a message sent before Earth had oceans, before mountains rose, before life dared to open its first trembling eyes. These ancient structures are fossils of the primordial universe, relics hinting that something vast and unpredictable governed the earliest shaping of cosmic matter. If the universe does not smooth out with distance, if irregularity is not an exception but a signature, what then becomes of our cherished models? Perhaps the Big Bang remains true, yet incomplete. Perhaps inflation unfolded unevenly. Perhaps the seeds of structure were sown by fields or forces we have not yet imagined. Cosmologist Max Tegmark once said, "The universe is not only stranger than we think, it is stranger than we can think." Somewhere in that strangeness lies the answer to whether the cosmos has boundaries at all. If it is not uniform, perhaps it is not symmetrical. And if it is not symmetrical, perhaps it is not finite in any way our minds can accept. The Great Wall and the Giant Arc may be hints of a universe that stretches without repetition, without simple order, without edges. To contemplate such a cosmos is to float in a slow, meditative drift through eternity. To sense that the darkness above us is not empty, but alive with ancient architecture. Places where gravity sculpted starlight into patterns older than our species. The night sky becomes a scripture written across billions of light years. Each galaxy a syllable, each cluster a chapter. And if our models prove incomplete, if the foundations of cosmology must be rewritten, then perhaps it is not a failure, but a gift. A chance to see the universe with new eyes, to rediscover wonder, to stand beneath the stars, not as creatures who understand everything, but as wanderers listening for the next whisper in the cosmic dark. For in the end, the universe has never been obligated to conform to us. It bends and stretches and evolves according to laws deeper than our brief existence. And when those laws reveal themselves anew, we are invited once more to learn, to marvel, to question, to drift with them across the infinite tapestry of space.